So in section 4.3, we are investigating parallel and perpendicular lines. So if you remember from the beginning of section 4.3, we learned that parallel lines are two lines or more that have the same exact slope, which gives the line the same steepness. And if a line has the same steepness as a different line, then they run parallel, which means they're at the same exact angle, so they never will touch. Today we're going to be looking at perpendicular lines, which is quite the opposite of parallel lines. So parallel lines never touch because they have the same slope, which gives the lines the same angle, so they run alongside of each other. Perpendicular lines do cross. They cross at one point, and when they do cross, you'll see that the lines create four different right angles, meaning that it crosses exactly at an angle that would create four 90-degree angles. So an example of that would be like a horizontal line intersecting with a vertical line. When a horizontal line intersects with a vertical line, you would see right angles at the intersection point because perpendicular lines create four 90-degree angles. What we're going to do here is the same exact exploration that we did with parallel lines. We're going to take these 6 equations and we are going to be solving them all for y by putting them into slope-intercept form. So what I want you to do in letter A and letter B is take all 3 of the equations in letter A and solve for y, all 3 of the equations in letter B and solve for y. Please pause the video and complete that, and then press play when you're ready. So solving the letter A equations for y, the first thing I would do for this first one here is subtract both sides by 3x. And I get 4y equals negative 3x plus 6. The last thing I'll do is divide everything by 4. I'm running out of space here, but when I do that, I'm going to get that my equation is y equals negative 3 over 4x plus 6 over 4 is the same thing as 3 over 2. Which is 1.5. I'm going to leave that in decimal form because that's easier for me to insert into my graphing calculator. Okay, the next one, same process, subtracting both sides by 3x first. I get negative 4y equals negative 3x plus 12, and then dividing everything by negative 4. I'm going to get here, a negative 3 divided by negative 4 will turn into a positive 3/4. X, and then 12 divided by negative 4 would be a minus 3. And then the last one, subtracting now both by 4x, I have negative 3y equals negative 4x plus 12, and then I'm going to divide everything by negative 3, and I get y equals, a negative divided by a negative is a positive, so negative 4x divided by negative 3 would be a positive 4 over 3x, and then minus 4. So what I'm going to do now is open up my graphing calculator, and I'm going to graph these all together. When I go to the y equals screen, your old equations from the last lesson might still be there, so you'll have to clear them out. Remember, if you don't have a graphing calculator, you should use and download, if you can, the Calculate 84 app. It's free and it does the same exact thing as the graphing calculator. So to get to the screen, I hit y equals, and then I'm going to be inserting these 3 equations into the y equals screen. So each y equals starts with y, so I don't have to write that. I just write the negative 3 divided by 4 x plus 1.5, and then 3 divided by 4 x minus 3, and then 4 divided by 3 x minus 4. Okay, now when I go to graph, I can't really see the whole thing because I have it zoomed in from the last problem. So I'm going to go to zoom and go down to zoom out. And then here is a better picture of these different equations. So when I'm looking at these equations, let's just remember the first equation that I have written down here is the blue line. The second one is the red line. And the third one is the black line. Okay. So when I go to hit graph, and now I'm looking at the equations with the color of their line. The first one, y equals negative 3/4 x plus 1.5, is this blue line here. Then the red line is this one here, this equation, and then the last one, this black line equation, is this here. So this one is kind of hard to tell that like which two equations are going to be perpendicular. But if you're looking at the blue versus the red, if I'm looking at those and just kind of pretending the black line isn't there, those angles, like this angle right here doesn't look like it's 90 degrees. Remember, 90 degrees is like a perfect right angle, so like where a wall meets a floor, like those are 90-degree angles. This one looks like it's a little bit more than that, so I don't think it's the blue and red one. So let me look at the red one and the black one. If I'm looking at the red and the black line, these angles right here are really small, and then this angle right here is really large. So we're looking for angles that look to be 4 right angles. So the two lines that I'm looking at then would be the blue and the black line. Okay, perpendicular lines cross so that you make 4 right angles. And I will be explaining what that means when it comes to your equations in just a second. If I go back to the other equations here, I can do the same exact thing for these 3 equations, solving these all for y. For the first one, the first thing I'll do is subtract both sides by 2x, and I get 5y equals negative 2x plus 10, and then I'm going to divide everything by 5, and I'm going to get y equals negative 2/5 x plus 2. And then for the next one, solving this one for y, I just add 2x to both sides, and I'm going to get y equals 2x plus 3. And then for the last one, to subtract 2.5x from both sides, I get negative y. Be careful, it's a negative y equals negative 2.5x plus 5. And to get rid of this negative, I have to divide everything by negative 1, which then will turn everything to be the opposite. This equation will end up being y equals positive 2.5x and then minus 5. It turned into a positive since a negative divided by a negative is a positive. Okay. Now what we can do is we can erase the other equations that we had in there, and we can insert these equations. So the first equation was y equals negative 2/5. And you know what? I'm going to insert parentheses here just to make sure calculator knows what to do here. So negative 2/5 x plus 2, and then y equals 2x plus 3, and then y equals 2.5 x minus 5. Okay. Now when I go to graph, I see the blue, the red, and the black line. And again, we're looking for 2 equations that cross at 90 degrees. So if I look at the blue versus the red, that doesn't look to me like exactly 90 degrees. If I look at the red and the black, these two are very close. Their slopes are very close. They're not parallel. I can see that this one is not increasing as fast as this one, so it can't be the red and the black. But if I look at the black and the blue line again, they do look like they cross at 90 degrees. So when we actually have 2 lines that are perpendicular, what happens is we will look at the slopes of those lines. Remember, parallel lines have the same slope, but perpendicular lines they're called opposite reciprocal slopes. So for both of these equations, the blue and the black lines were perpendicular in this set and this set. So if we investigate these equations closely, let me rewrite them down here. The 2 equations that are perpendicular are y equals negative 3/4 x plus 1.5 and y equals 4/3x minus 4. Perpendicular slopes do not have the same exact slope. That's what parallel slopes have. Perpendicular slopes are called opposite reciprocals. That means that one is negative, one's going to be positive. So you can see that this one is a negative slope, whereas this one is a positive slope. So I can see that because this is a negative number, this is a positive number. And then the reciprocal part means that the fraction flipped upside down. So this is 3/4, and this flips to be 4/3. The same thing happens with the second example. So I'll write these equations very small down here. The first equation is y equals negative 2/5 x plus 2. And the second equation is not in fraction form. 2.5 is the same thing as 5 over 2. So I'm going to rewrite this as y equals 5 over 2x and then minus 5. Looking at the slopes of these lines again, I can see that one is a negative slope, one is a positive slope, and the fractions are flipped upside down. So this is 2 over 5, this is 5 over 2. Whenever you have slopes that look like this, where one is positive, one is negative, and they are flipped upside down, meaning reciprocals, that means they are actually perpendicular. So looking at these communicating your answers questions, they're asking us to recognize lines as parallel or perpendicular. So we know that parallel lines, they have the same slope. Okay, so for example, y equals 2/3 x plus 1 and y equals 2/3 x plus 5. They have the same slope. Both of these equations have a slope of 2/3, meaning that they will be parallel. They'll never cross because they have the same steepness. Perpendicular lines, though, they do not have the same slope. They have a slope that's called opposite reciprocals. Opposite reciprocals means that if one is like y equals negative, let's say 3/5 x plus 1, so if one slope is negative 3/5, that means that the other slope has to be the opposite of that. The opposite of negative is positive. The opposite of 3/5 upside down is 5/3. So it would be like y equals 5/3 x and then plus whatever number. The y-intercepts don't ever matter. You only look at the slopes because the y-intercepts are just showing where the line starts, which doesn't actually matter. So number 4 and 5, they're asking us to compare the lines and the slopes in these explorations, which we already did. We can tell if two lines are parallel by looking at their slopes. If the slopes are the same, then they'll be parallel. If the slopes are opposite reciprocals, they will be perpendicular. So if we go to this page here is page 31. We already completed some parts of this page, but we did not yet complete this part here. How can you tell that two lines are perpendicular by looking at their equations? Please pause the video and write how you can tell two lines are perpendicular. Okay, hopefully you wrote down that two lines are perpendicular if they have opposite reciprocal slopes. For example, if one slope, let's say slope number 1, is, let's say, 1/4, then slope number 2, you have to flip 1/4 upside down. So 1/4 upside down is 4 over 1. And because this is a positive number, this one would have to be negative. So this one would be negative 4 over 1, or in our world, we just would say negative 4 because we don't necessarily need the 1. We completed number 1 for our last lesson. So looking at number 2, it's asking us to write an equation of a line that's actually parallel. So this one's not what we just did. So it says write an equation of a line that passes through 3, 1 and is parallel to this equation. When you're looking for parallel and perpendicular lines, all you're looking for is the slope. So parallel lines have the same slope. So in order to be parallel to this line, our slope also has to be equal to 3. So the slope that we need for our equation is going to be 3, and the point that we're using is the point 3, 1. Right now we have two things, and we need to make an equation. You have two options. Since we have the slope and a point, you can use the formula that requires you to have a slope and a point, and that's called point-slope form. I think that's the easiest way to go about it. Or you can use slope-intercept form, y equals mx plus b, but then you'll actually have to solve for the y-intercept because they don't give it to you. I'm going to use point-slope form because that's the easiest way to do it. Y minus y1 equals your slope times x minus x1 is the formula. This right here represents our m value, This represents our x1, this represents our y1. Using these numbers and replacing them into the variables, the formula for this equation would be y minus 1 equals 3 times x minus 3. Okay, and then in example 3, it's asking us to determine if the lines given are parallel or perpendicular. So in order to do that, we have to look at all three equations in a way that we can see their slopes. I can see the slope of the first equation. The first equation slope is 2/3. In order for the other lines to be parallel to it, they also have to have slopes of 2/3. In order for the other lines to be perpendicular to it, they would have to have slopes of -3/2. Both of those equations, though, are not right now in the correct form. In order to see the slope, I either need it to be in point slope form or slope-intercept form. The easiest thing to do is to take these two equations and put them into slope-intercept form by solving for a y. So to do that, I would subtract both sides by 3x. I get 2y equals -3x plus 8. I divide everything by 2. And the equation here is y equals -3/2x plus 4. Okay, I'm going to do the same thing for the next one, and then I'm going to see what's going on here. For this one, I'm going to add 2x to both sides. And I have 3y equals 2x minus 9. And then I'm going to divide everything by 3. And I get y equals 2/3 x minus 3. Okay, so right now we are determining which lines are parallel or perpendicular. So if I'm going to call this line 1, this line 2, and this line 3, before I tell you the answer, let's just think about it. Line 1 and line 2 are a type of line. Look at the slopes of both of these lines. The slope of this line is 2/3. The slope of this line is -3/2. They are not the same, but they are opposite reciprocals. That means that they are perpendicular. So line 1 and 2 are perpendicular. All right. Let's look at line 1 and line 3. Line 1's slope is 2/3. Line 3's slope is also 2/3. So that means that line 1 and 3, since they are the same exact slope, they are parallel. And the last combination of lines would be line 2 and 3. So line 2, its slope is -3/2, and line 3's slope is 2/3. Well, since these are opposite reciprocals,